Welcome back. So today we're going to be talking about arcs and chords. So we're going to start out with a theorem and some vocabulary. So theorem 10.2 says in a circle or in congruent circles, two minor arcs are considered congruent if and only if their corresponding chords are congruent. Okay, so if you look at our picture, we have chord A, B, and chord C, D. So if those are congruent, then we know that these arcs, arc A, B, and arc C, D, are congruent to each other. And the inverse is also the same. If we know that those arcs are congruent, then we know that the chords are also congruent. Okay, next is some vocabulary. We have inscribed and circumscribed. So inscribed means a polygon has all of its vertices on the circle or the other shape that it is inscribed in. So for this one we have quadrilateral ABCD is inscribed in circle E. So you'll notice all four vertices are on that circle. Okay, and every piece of the quadrilateral is inside of the circle. Circumscribed is what the circle is. So circumscribed means that the polygon is contained inside of the shape. Every bit of it is inside. So the one on the outside is circumscribed, the one on the inside is inscribed. Okay, let's do an example. Alright, so we're working with a snowflake. The main veins of a snowflake create 6 congruent angles. So we're going to determine whether the hexagon containing the flake is regular or not. So if we look at our picture over here, we have our 6 different angles. They said those are all congruent. So we know angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4, which is congruent to angle 5, which is congruent to angle 6. Okay, so we have all 6 of our angles are congruent to each other. So since all 6 of those are congruent to each other, we also know that these arcs all have to be congruent to each other. So we can say KL, arc KL, is congruent to arc LM, which is congruent to arc MN, which is congruent to arc NO, which is congruent to arc OJ, which is congruent to arc JK. So all 6 of our arcs are also congruent. And then if you remember back to that theorem, it says if the arcs are congruent, then the chords are also congruent. So we can also say that chord KL is congruent to LM, which is congruent to MN, which is congruent to NO, congruent to OJ, and congruent to JK. Since all of those things are congruent, the next thing we're going to look at is the actual triangle. So let's start here with triangle 1. Okay, so we have these 2 radii are going to be the same, so we know that these angles opposite of them also have to be the same. Okay, so for our sum theorem, we know that the measure of angle 1 plus, we'll call these angles x, since they have to be the same. X plus x equals 180. That's our triangle sum theorem. So then what is the size of angle 1? Since we know all 6 of these are the same, we're going to take 360 divided by 6 equals the measure of angle 1. And that comes out to be 60. So we're going to plug that into our equation. So from here, we have 60 plus 2x equals 180. So if I subtract my 60, I get 2x equals 120. Dividing by 2, x equals 60. So each one of these is 60. So then if we look at this shape, we know angle K is 120 degrees. Angle L is 120 degrees. Angle M is 120. Angle N is 120. Angle O is 120. And angle J is 120. So this is a regular hexagon. If you remember, a regular hexagon means all of your sides, and we found all of those chords are congruent, and all of the angles are congruent, and we just found down here all of the angles are congruent. So that is a regular hexagon. Alright, so let's look at a couple more theorems. So we have theorem 10.3 says in a circle, if the diameter or radius is perpendicular to a chord, then it bisects that chord and its arc. Okay, so we have a diameter BA, it's perpendicular to TV, so we know it bisects TV, so TU and UV are congruent. It bisects the chord and the arc, so that means TA and AV are also congruent. So then the next piece is theorem 10.4. In a circle or in congruent circles, two chords are congruent if they are equidistant from the center. So if they're the same distance from the center and the circles are congruent, then the chords are also congruent. Alright, so let's do a couple examples with that. Alright, so we have circle O. It has a radius of 13 inches. Radius OB is perpendicular to chord CD, so we have the perpendicular marked here. Let's see, which is 24 inches long, so our chord is 24 inches long. It says if the measure of arc CD is 34, we're going to be finding CB. I apologize, that should be CB. Okay? Alright, so this whole arc is 134. We want to find CB, just half of it. So we know from this theorem right here that it bisects it. If it's perpendicular, then it bisects it, so that means it's half. So the measure of CB equals 1/2 the measure of CD. We know that CD is 134, so 1/2 of 134. 1/2 of 134, we end up with 67. Let me check my math there. 60 would be 120, and then another 14. Half of that is 7, so 67. Okay, so the measure of that one is 67. So then the next piece that we have is we're going to be finding OX. So the first thing we're going to do here, let me slide up just a little bit here, is we're going to draw a radius from O to C, or C to O. We're making a triangle here. Okay, so now we have a right triangle. We know that CO is a radius, so it's going to be 13 inches, just like the radius was at the top. So CO equals 13 inches. Okay, it says OB bisects CD. Okay, because we said it's perpendicular, so we know it bisects that. So if the whole thing is 24, then we know this piece has to be 12. So CD, half of CD is CX. 1/2 of 24 equals 12. So CX is 12. So I'm actually going to bring my triangle down here so it's a little easier to see what's happening there. So this is C, this is X, this is O. So we said CO was 13, we said CX is 12, and we're trying to find OX, which is this piece here. So we have a right triangle. Anytime we have a right triangle, we're going to be using Pythagorean theorem. So we have our two legs. So I have 12 squared plus x squared equals 13 squared. Okay? Alright, so I'm just going to slide that up since I have everything moved down. So 12 squared, we're looking at 144 plus x squared equals 13 squared, which is 169. So then from there I'm going to subtract my 144. I get x squared equals 25. Square root of both sides, x equals 5. So this is 5. So then I'm going to come over here and I'm going to say, oh, x equals 5, and that's inches. And that is my final answer for that one. Okay, let's do one more example here. So this one has to do with our 10-4 theorem, where we had two chords are congruent if and only if they are equidistant from the center. So we have chords AC. So chord AC is up here. Scoot that over just a little bit for you. And then we have chord DF. DF is over on the left. They are equidistant from the center if the radius of circle G is 26. We're going to find AC and DE. So we're going to find the lengths of these chords. We know they have to be congruent because, again, we said they are equidistant from the center. Okay, so for this one, we're going to first start out just like we did before. We're going to draw some right triangles in here. So from A to G and from F to G. So now we have some right triangles going on. And I know AB squared, which is one of my legs, plus BG squared, which is my other leg, equals AG squared, which is my hypotenuse that I just drew, which is also a radius. We know the radius is 26, so I'm going to go ahead and plug that in. And then other information that we know, I apologize, I didn't label these on here, but we do know they are equidistant from the center. They are actually 10 units from the center, so we're going to plug that in for BG. So this is 10 squared. And then AB, the hypotenuse, or excuse me, my other leg, AB, is what we're trying to find. Okay, so we're just going to solve this for AB. So 26 squared, it's 676. So 676 equals 10 squared, which is 100, plus AB squared. So then to solve, we're going to subtract our 100 from both sides. So we get AB squared equals, I have 576 left. So I'm going to do square root of both of my sides. I get AB equals, I'm getting 24. 24. Okay, so I have 24 that I can write in there. Alright, so then it asked for AC. I found AB, it asked for AC. We know since this is perpendicular that this is half of the whole thing. So 2AB equals AC. We found AB to be 24. 2 times 24 equals AC. So 48 equals AC. We know since these chords are equidistant from the center that AC is congruent to FD. Okay, but they asked for DE, which is only a piece. Okay, so if AC is 48. It's congruent to FD. So then we know for our chords, FD is the whole thing, DE is a piece, so DE equals half of FD. So DE equals 1/2 of 48. DE equals 24. So we have DE, we have AC. Those are the two pieces it asked for, so we are finished. That's all I have for today. I'll see you in class tomorrow.